Hello everyone, welcome back to my YouTube channel. Myself Grishma, I am pursuing my BE in Sri Venkateshwara College of Engineering. Today's course title is Introduction to Civil Engineering. Course code BESCK104A. Topic Determining the centroid. Contents that we are going to learn in this PPT are centroid, moment of inertia, parallel axis theorem, perpendicular axis theorem, radius of gyration, tips to solve problems on centroid, numerical problems. Defining centroid and its importance. What is centroid? The centroid is the geometric center of plane figure or a three-dimensional object. It represents the average location of area or volume of shape. Importance of centroid in civil engineering. Determining the centroid is crucial in structural analysis and design as it helps calculate the center of mass, moment of inertia, and other important properties. Estimating location of centroid. By drawing at least two lines, each of which seems to divide the area into two parts, each of which appears to have the same moment about the line, the intersection of these lines should locate the centroid approximately. Definition of moment of inertia. Moment of inertia of body about any axis is equal to the product of area of body and the square of distance of its centroid from that axis. That is, moment of inertia is equals to ay square. Generally, moment of inertia equals ah square, where a is area of section, h is distance of centroid of area of section from the axis considered. I equals moment of inertia about the axis considered. Theorem of perpendicular axis, polar axis theorem. The third axis ZZ is perpendicular to XX and YY axis is called as polar axis. It states that if IXX and IYY be the moment of inertia of plane section about two mutual perpendicular axes passing through origin, then moment of inertia of polar axis IZZ denoted by IP is given by IXX plus IYY. That is, IP equals to IZZ, which is equal to IXX plus IYY. Theorem of parallel axis. It states that the moment of inertia of plane section about any axis parallel to the centroidal axis is equal to the moment of inertia of section about the centroidal axis, the product of the area of the section and square of the distance h square between the two axes. For circle, area equals pi r square, Ix which is equals to Iy which is equals pi r4 divided by 64. For a rectangle, area equals b into h, for Ix bh cube by 12, Iy equals hb cube by 12. For triangle, area equals 0 of into breadth into height, for Ix bh cube by 36 and for Iy hb cube by 36. Radius of gyration. The distance at which area is supposed to be concentrated to give the same moment of inertia is called as radius of gyration. Ixx is equals to ak square, kxs equals square root of Ixs divided by a, kyy is equals to square root of Iyy divided by a, where k is radius of gyration of the axis considered. Steps for following problems on centroid. Step 1. Identify given reference axis. If reference axis is not given, consider the bottommost part of figure as x-axis and leftmost of the figure as y-axis. Step 2. Check the symmetric of the figure. If the figure is symmetric about vertical axis, then x bar is equals to total width of the figure divided by 2. Similarly, if the figure is symmetrical about horizontal axis, then y bar is equal to total depth of the figure divided by 2. Step 3. If a figure is asymmetric, then divide the composite section into non-geometric figures. Step 4. Determining the centroid of geometric figure using following table. This is the table that have component area, centroidal distance from x-axis, that is y, centroidal distance from y-axis, that is x, moment of area about x-axis, that is ay, moment of area about y-axis, that is ax. Now this is the problem that we are going to solve. Determining the position of centroid for the lamina with a circular cut. In this figure, they have not given the reference axis, so we consider bottommost part of figure as reference axis and leftmost part of the figure as y-axis. In this figure, we have four components, that is rectangle, triangle, semicircle and circle. First one is rectangle with breadth 120 mm and the depth 100 mm. Second one, triangle with the base 120 mm and the height 60 mm. Third one is semicircle with radius 50 mm. Fourth one is circle with radius 20 mm. Now we have the table of component: area, centroidal distance from x-axis, that is y, centroidal distance from y-axis, that is x, moment of inertia about area about x-axis ay, moment of area about y-axis, that is ax. First one is rectangle. For area, breadth into depth, that is 120 into 100 gives 12,000. The centroidal distance from x-axis d by 2, which is equals to 100 by 2, that is 50. Centroidal distance from y-axis b by 2, that is 120 by 2, that is 60. Moment of area about x-axis ay, a into y, a means area, y is centroidal distance from x-axis. 12,000 into 50 gives 6 lakh. Moment of area about y-axis, that is ax, a into x, where a is area and x is centroidal distance from y-axis. 12,000 into 60 gives 7,20,000. Second one is triangle. Area of triangle is given by the formula of into base into height, that is of into 120 into 60 gives 3,600. Centroidal distance from x-axis for triangle is given by h by 3 plus 100, where 60 by 3 plus 100 gives 120. Centroidal distance from y-axis, that is x, for triangle is given by b by 3, that is 120 by 3, which gives 40. Moment of area about x-axis, that is ay, for triangle is given by area, that is 3,600 into y, that is 120, gives 4,32,000. Moment of area about x-axis, that is ax, for triangle is given by 3,600 into 40, that is 1,44,000. Third one is semicircle. Area of semicircle is given by pi r square by 2. Pi into r is 50, so we take pi into 50 square by 2. We get 3,927. Centroid distance from x-axis, that is y, for semicircle it is given by r, so therefore r equals 50. Centroidal distance from y-axis, that is x, for semicircle it is given by the formula 4r by 3 pi plus 120, which gives 141.23. Moment of area about x-axis, that is ay, for semicircle is given by area into y, that is centroidal distance from x-axis. 3,927 into 50, we get 1,96,350. Moment of area about y-axis, ax is given by a into x, we get 3,927 into 141.23, we get 5,54,327. And the last one is circle. Area of circle is given by pi r square. We are calculating circle in the with negative, so that we get answer minus 1,256.63. Centroidal distance from x-axis, that is y, for circle is given by r, that is 100 divided by 2, which equals 50. Centroidal distance from y-axis, that is x, for circle is given by 120 by 2, that is 60. Moment of area about x-axis, that is ay, a is area where y is centroidal distance from x-axis, minus 1,256.63 into 50 gives minus 62,832. Moment of area about y-axis, that is ax, where a is area and x is centroidal distance from y-axis, minus 1256.63 into 60 gives minus 75,398.4. At last, we have to calculate the summation of area, summation of moment of area about x-axis, that is AY, moment of area about y-axis, that is AX. Now, summation of area is 18,270.36. Summation of moment of inertia about x-axis, that is AY, is 11,65,518. Summation of moment of area about y-axis, that is AX, is 13,43,172. At last, we have to calculate x bar. X bar is given by the formula summation of AX divided by summation of area, that is 1,34,372.54 divided by 18,270.36 gives 78.52 mm. Y bar is given by the formula for summation of AY divided by summation of A, which is equals to 11,65,518 divided by 18,270.36, which gives 63.79 mm. Thank you for watching my video. Please do like, share and subscribe.